Brace yourself. I would like to start with a small joke because I'm the last speaker in the session immediately after lunch. So, good afternoon, respected veterans, everybody on the panel, officers, ladies and gentlemen. In the next 15 minutes, I will try to give an insight into maritime UAV roles, our requirements, and what the industry would like to know from a naval operations perspective. I'll give you a quick overview of our geography, our present security scenario, a small brief on the naval unmanned roadmap requirement, our present capabilities, and conclude with future plans and our requirements. Given the time, I will only touch upon these aspects and be glad to answer any queries separately. So one of my seniors showed me the inverted map of India, and it presents a better perspective of the Indian Ocean and exactly why it is called the Indian Ocean in the first place, with our peninsula mass which juts out nearly 2,000 kilometers into the sea. Now, this is a snapshot of the vessel traffic monitoring system, and at any given point, there are thousands of vessels transiting the Indian Ocean region. And these are just large merchant traffic only. We add to this hundreds of thousands of smaller fishing boats, and the quantum of surveillance required, not only on the surface, the subsurface, and also in the air. This is just to give you a picture. And to highlight our surveillance challenge, the Indian Ocean is spread over an area of 68.56 million square kilometers, connecting over 35 littoral nations. Recently, when the cylinder prices went up in the West Asia crisis, every village and every household in India understood what is the Strait of Hormuz. Now, apart from Hormuz, we have so many other critical maritime trade entry points, what we call choke points, which we need to monitor as shown. Now, during a conflict, identification of neutrals and every element in this entire canvas of operations, it results in our necessity of persistent surveillance, not only on the surface, but also in the air and underwater domains. Modern naval warfare is undergoing a revolutionary transformation with the integration of unmanned systems, traditionally dominated by large ships, submarines, and manned aircraft. Today, forces around the globe are leveraging the power of unmanned systems, not only in the roles which have been previously enumerated in the previous sessions, but also electronic warfare and more recently, op logistics also. The market value in this sector, as highlighted in the first session, was about $100 billion overall, but just the maritime sector is likely to rise to about $35 billion in the coming decade. So this is an input for all the industry reps. The envisaged roadmap for the Indian Navy's unmanned systems is broadly as shown. While today's event is restricted to unmanned aerial systems only, the Navy's unmanned roadmap includes surface and subsurface unmanned systems in addition. Now, towards maintaining India's status as preferred security partner in the Indian Ocean region, it is envisioned that all repetitive and time-intensive tasks would predominantly be taken over by uncrewed systems. For example, maintaining unbroken surveillance, tactical logistics at sea, overwhelming enemy air defense, kamikaze strikes, loitering munitions, tracking of submarines. It's a vast canvas spanning the entire spectrum of maritime operations. Now I'll give you a brief into what we presently have and then onto what we want to have. You would have seen in the news that we've leased 2 MQ-9B Sea Guardian from General Atomics, and the audience is well aware our armed forces has placed an order for 31 of these aircraft, of which 15 would be for the Navy. These aircraft have already flown about 30,000 hours and are undertaking ISR missions not only for the Navy but also for the Army and the Air Force. The new contract will also be, those aircraft will also be equipped with air-to-surface missiles and anti-submarine warfare suite, including sonobuoys, giving a fillip to our persistent surveillance capability in surface and underwater domains. And in the future, we also would like to have indigenous HALE RPAs, and that's why we have called so many industry partners today. These aircraft are giving us, we could not get a reasonable time on task in the far-flung areas of the Indian Ocean region, but today, with the HALE RPAs coming in, we are able to maintain near continuous surveillance at the fringes of the Indian Ocean region. We also have procured two Drishti 10 along with the payloads from Adani Defense. They've got an EOIR payload, patrol radar, ESM and common payloads. And unlike segregated airspace where specific zones are set aside for military use, these RPAs are STANAG certified to fly in non-segregated airspace, that is along with civilian manned aircraft. And an indigenous armed version of these RPAs is envisioned to be inducted in the future. The Herons, made by Israeli Aerospace, Herons have been serving all the three services since 2003. They have a proven track record for coastal surveillance and in surveillance in REZ. We've also procured 8 rotary wing campcopters called NSUAS. One big model is in the lobby, many of you have seen. This is equipped with a maritime patrol radar, a EO payload and AIS payload, and with an endurance of over 5 hours. It is designed to provide surveillance and early warning of approaching threats to the ships at sea. Indian Navy also possesses various types of loitering munitions. The picture is only for reference, but we aim to have this precision strike capability. We are looking for long-range precision targeting with a man in the loop and autonomous systems in an area denial role. For example, if you don't want Chinese ships to come to a particular area, you deploy loitering munitions there to have an area denial kind of a role. Lastly, we also use spotter drones for surveillance of ships and anti-piracy, anti-hijacking operations. It helps us see the blind side of ships during such operations. And now I'd also like to highlight a few technologies which we are focusing on. New technology, as already covered by my fellow panelist, MUMTI. This is the latest trend in application. So I'll not dwell onto it. What I want to highlight is what we are looking for. It's something like this. We are looking for an aircrew in a PATI or a helicopter to take full mission control of another RPA or UAV, fly the drone to a location, use their sensors, and once completed, they either hand over control to a shore-based crew or they could be expendable drones launched from the aircraft itself. Next up is the swarm technology. A lot of people have spoken about it. It could be used in our naval context to saturate air defense systems or create a robust surveillance system on the surface, in the air, and enable persistent surveillance in the underwater domain also. The picture highlighted is a wave glider. We also, you would have heard about Navy interest in HAPS, like aircraft systems flying at about 18 to 25 kilometers. They stay there for prolonged durations. You would have seen in the news that we've signed a contract with New Space Technologies to develop HAPS. The Navy is also looking for unmanned combat aerial vehicles which can be launched from carriers and can be controlled via SATCOM. This is something like the wingman concept also covered earlier. We're also looking for combat air teaming system, which is another indigenous concept. This platform emphasizes low observability, allowing it to operate in contested environments. Now, one key feature which the Navy requires is a wing folding mechanism so that it is suitable for ship-based deployment where space is extremely limited. A system could potentially support surveillance, strike missions, electronic warfare, and this represents Navy's move towards autonomous and network-centric naval aviation. Another new concept, you would have seen the DISC challenge, rearming by drone at sea. It is designed to enable ship-to-ship transfer of missile canisters or similar equipment without requiring the ships to return to harbor. So this is a requirement of heavy lift, multi-rotor unmanned aerial vehicles capable of reloading missiles into the cells at sea. A drone carrier penetrating air control is an important element of naval air warfare. Under this requirement, we are looking for RPA launching aircraft, which has attracted extensive attention due to its advantages, because the mother aircraft is capable of carrying and launching multiple smaller RPAs, as covered by my panelist in the previous presentation. The technologies we are looking for in this field are cognitive AI, resilient communication systems, autonomous decision making, and launch and navigation control technologies. Coming to what we require from the industry, we have a lot of problems with foreign vendors because they bring a host of issues, especially with respect to integration of critical components like SDR radios, IFF, own weapon systems, etc. So our reliance on foreign vendors for payloads needs to cease. In times of conflict, when we need higher levels of readiness and serviceability, our reliance on foreign vendors can hurt us. And continuous software upgrades undertaken by various OEMs, they can bypass certain VA protocols, something which we wish to avoid in the first place. So I urge the industry partners to go through our naval aviation roadmap. It's available online, and the Indian Navy's unmanned roadmap to understand the kind of technologies that we are looking for. We would like to follow the triple helix model between the government, industry, and university. The government provides funding, the industry contributes resources and expertise, and academia generates knowledge through research, and together they form an interconnected network to generate ideas. And we need this quick adaptability, which we have seen in the recent conflicts in Ukraine, and where quick adaptability has become a key, where we also need mass production to accompany quick adaptability. With that, I hope to have piqued your interest and open to discussions if any. Thank you, sir.